Modelling motion lesson 4, we're going to look at forces and the triangle of forces. So we're going to review definitions regarding force first, explore and apply Newton's first law, and solve force problems using the triangle of forces approach. Force. Force is a vector quantity. It has both magnitude and direction. In SI units, the standard unit of force is the Newton, given the symbol N. Newton is a derived unit defined through Newton's law, second law of motion. A force of 1 unit causes a 1 kilogram mass to accelerate at 1 meter per second squared. The fundamental unit of force in the SI unit convention is kilograms per meters per second squared. Newton's first law of motion. In the absence of external forces, and when viewed from an inertial reference frame, an object at rest remains at rest, and an object in motion continues in motion with a constant velocity. Types of forces. You have field forces such as gravity and electrical. They act without physical contact between objects. Applied force, pushes or pulls exerted on objects due to contact. And resistive forces such as air drag and friction are examples of resistive forces. This occurs when two objects move or attempt to move relative to one another. Force notation. In this section of work, forces are generally denoted as force 2, which refers to a force number 2, so using the subscript here. This might be represented in terms of components using I's and J's. Weight as a force might be denoted in terms of horizontal and vertical in the form weight X and weight Y if you were to break up the components horizontally and vertically. Particle. In Newtonian dynamics, a particle is used to model an object and is taken to be a point. A particle in principle can model the movement of a bullet, a car, or a planet, provided we accept the model as the approximation to the motion of the real objects that they represent. Resultant force. The vector sum of the forces acting at a point is called the resultant force. The triangle of forces is often applied when calculating a resultant force. Let's consider three forces here, X, Y, and Z. If the equilibrium, the resultant force is 0, we can draw a triangle of forces diagram. At that point, we can use a sine or cosine rule for non-right angle triangles to determine various values. The vector diagram below shows the combination of three vectors. So I've got vector 1, 2, and 3. And those three vectors can then be translated into a triangle of forces. So I've got vector 1 here, vector 2, and vector 3. The same three vectors are drawn as a triangle. The reason is because the net force is 0. If it wasn't a stable system with a net force of 0, I wouldn't be able to do that. Calculate the magnitude and direction of the resultant force of the forces 20 newtons and 16 newtons acting on a particle at O as shown in this diagram. We're going to apply trigonometric rules here to solve this one. So we have a force of 20 newtons and 16 newtons. So we're going to draw a triangle to represent the three forces. Well, the third force would be the resultant force. So our first one from A to B is our vector, which is making 45 degrees from the horizontal and 20 newtons. It's this one here. Our second one is then 16 newtons, and our resultant force is the tail of our first one to the head of our second one. So AC is our resultant force. We're going to work out angle ABC, which is in here first. That's actually 45 plus 60. Why? The angle in here is 30 degrees, hence the angle in there is 60. Using the Z rule again, that's 45, hence that's 45. 45 plus 60, angle ABC is 105 degrees. Now we have a side and an angle on the side. We can use the cosine rule to find out the magnitude of AC. So we've got our triangle with forces 20 and 16, the angle's 105 degrees between them. We're going to work out the magnitude of AC, which is force 3. So apply the cosine rule to determine B. B squared equals A squared plus C squared minus 2AC cos B. Subbing our values of 16, 20, and 105, we can now evaluate that as being AC, which is force 3's magnitude, is 28.66 newtons. Now all we want to do is work out the angle AC makes with the positive x-axis. I know this angle in here is 45. If I can work out angle BAC, which is in here, I can add those two together, and then I can work out the remaining complement of the angle here. So apply the sine rule to determine BAC. So we'll call BAC angle A. So A over sine A equals B over sine B. So my A is 16 over sine A. My 28.66, which is this side, over sine 105. If I isolate A and solve for A, my angle A is 32.62 degrees. So note, that's 45, that's 32.62. So to work out that angle from the positive x-axis, I'm going to have 90, subtract 45, subtract 32.62. That angle is 2.37 degrees. Magnitude is 28.66 newtons. Example 19. A particle is suspended by two ropes, tension 1 and tension 2, attached to a horizontal plane. Calculate the tension in both ropes. So we're going to consider the stable is suspended, meaning the system is in equilibrium, meaning the resultant force is 0. Hence, we've got 1, 2, 3 vectors. We can create a triangle of forces. So construct a triangle of forces. First up, I want to create this horizontal line here. The reference point there is P. Now I'm going to create that same line down here. That way, if I can think of that line, horizontal line, the angle between that horizontal line and that vector there would be 50 degrees. Hence, that same angle there is 50 degrees from this point. Using the Z rule, if I create another horizontal line up here, that would be 50 degrees in here. Now I'm going to join tension 2 onto that point. Using the Z rule between 32 and 32, that angle in there is 32. Now, if I construct that line here and make a tension 2, I know that this one is vertical, only having a J component. So I've extended those two lines there and created a vertical line here. Now I have my triangle of forces. So I've got a tension 1, a tension 2, and my weight is 100 G, which is 100 gravity. Taking that diagram to the next page, we have apply the sine rule because I have a magnitude on this side and I have the angle, opposing angle in the triangle, which is 82 degrees. So 100 G over sine 82 equals tension 1 over sine 58, which equals tension 2 over sine 40. Calculate tension 1 first. If I then multiply both sides by sine 58, tension 1 is 85.64 G newtons. Same with tension 2, 100 G over sine 82 equals tension 2 over sine 40. Multiply both sides by sine 40, and tension 2 is 64.91 G newtons. That's the end of lesson 4, which is just exploring forces and the triangle of forces. Test your understanding, calculate the magnitude and direction, the resultant force of the forces acting on a particle shown in the diagram using trig rules. So examine that diagram and see if you can use the triangle of forces to work out the answer.